I fill that role for the CSS club, and I will be hosting this workshop. But I am excited to see, about this programming language. I haven't even heard of it, so I think this will be a good introduction for me as well.
Yeah, awesome.
I'm always open to learn like new frameworks and whatnot.
Yeah, and Keaton, am I pronouncing it correct?
Yeah, that's fine.
Keaton, your audio is coming through really quiet on my end. I don't know if that's coming in for other folks as well.
All
But I
right.
just wanted to give you a heads up on that. I
Yeah.
can hear you. I just have to like think harder to make sure that I'm understanding, if you know what I mean.
Uh, does this sound a little bit better? I'm not sure. Let me try this out.
I was really excited when I got the email for this thing because I'm actually building a project on my own, like a side project that uses Julia for a big part of it.
Oh, sick. Nice, Joshua. What are you using it for?
So it's like it's a synthesizer, so it makes noises. It's a modular synthesizer, which means you can connect things together, like connect different modules together to build up sounds. So the modules themselves that do the audio processing are programmed in Julia. I picked it because it allows for like real-time optimization depending on how the user has linked up their modules.
Sick. Sick,
Yeah,
sick.
what do the modules entail? Like what constitutes a module? I'm not familiar.
So like a really basic one is an amplifier. So like makes the sound louder or quieter. There's also an oscillator, which takes a waveform and repeats it to make some kind of tone. There's an envelope that makes things go up and down over time. So you can use that to like make it so that when you let go of a note, the volume kind of fades out. Yeah, I'm gonna put a GitHub link, shameless self-promotion, into the chat.
What's the input for the sound? Is it like is there some sort of UI that you're like, oh, okay, yeah, I see it. That's very cool.
It's designed to work with, there's like a standalone version. If you have like a MIDI keyboard plugged in, I also just like this morning added so you can just play it on like a regular QWERTY keyboard just to test it out. You can also load it up as like a plugin in music software. So then you can like compose music in the software and then it plays it using this synthesizer.
That is very cool. Neat. I'm excited to spend a little bit more time checking it out.
All right then. Well, with that being said, I think my mic is sounding a little bit better now. Nice. So we'll get started with the workshop and everything. So hello everyone that's joining in. We are looking forward to what we have in store for you guys today. Today with us we have Logan Kilpatrick with us. He will be taking us through a workshop of a programming language called Julia. Me personally, I have not used it, nor have I really heard of it. But yeah, we are really excited to actually see what this is about. And yeah, I think with that being said, I'll allow you to introduce yourself, Logan.
Totally. Thank you. I appreciate the introduction, and I'm super stoked to be here. And I think honestly, it's always great to meet people who know nothing about Julia, and sort of I get to be the one to share the good news and all of that. So my name is Logan Kilpatrick. I currently serve as the community manager for the Julia programming language. I started that role back in the beginning of 2020. I'm also sort of completely independent of the Julia work that I do. I'm a software engineer at Apple. So if you ever want to chat about that, feel free to ping me offline. But yeah, so I got involved with Julia when I was interning at NASA, and the project that I was using just sort of happened to use Julia. So I was sort of forced to get involved. It wasn't necessarily a conscious choice that I made, but it's sort of been a great experience so far. So I'll go ahead and share my screen. which is currently disabled.
Okay, yeah, that's fine. So while I'm doing that, actually, we actually have an announcement from our treasurer, Pratista. So I'll go ahead and let her make an announcement while I give you the co-host permission.
All right, thank you, Keaton. Hello, everyone. My name is Pratista, and I just wanted to make a quick announcement. For those of you guys that signed up for the t-shirts and the graduation stoles, the forms have been emailed out to you guys, so please make sure you guys fill that out, and make sure to Venmo Sandra if you have to. So if you're a paid member, you don't have to Venmo as much, so you guys have a discount, and if you're not a paid member, it's a little bit higher. But that's coming up, so the t-shirts will be due this Friday, so make sure you fill that out as soon as possible. And then for those of you guys that are part of CSSMP, the mentors, please reach out to either me or Ricky with an availability time as soon as possible. So communicate with your team and just let us know what time works for all of you guys, so we can do the guideline meeting with you guys as soon as possible. We're trying to get it done by this weekend, and if not, then possibly next weekend would be ideal. And that was it. And make sure you guys sign in a sign-in sheet. It should be in the chat as well. Thank you.
Yeah, thank you very much. So yeah, those reminders are very vital for you guys' t-shirts, graduation stoles, and for those participating in the CSSMP program. So make sure to take care of those as soon as possible. And now, without further ado, Logan, I think I gave you co-host permission, so you should be able to share screen. And yeah, let's dive right into it.
Awesome, let's do it. I think everybody should be able to share, should be able to see my screen right now. So let's go ahead and take a look at some slides, and then we'll, again, just for folks who haven't heard about Julia before, which it sounds like that's sort of the majority of people, let's dive in and take a really high level look. So I think the sort of context in which it makes a lot of sense to think about Julia is sort of from a historical context. If you think about sort of the development life cycle for real companies over the last 25 years, you sort of have this, what many folks might have heard before, it's called the two-language problem, where you sort of have all these people who are perhaps more focused on science and less on computer science, software engineering. And those people are sort of doing all their development using Python, using MATLAB, some of these more high-level tools. And then when you build something using sort of science and something really interesting and cool, and you want to actually go and turn that into a real product and release that to the world, you actually end up rewriting your application using whether it's B, C++, Java, in a lot of cases C, and then you go and you deploy whatever that solution is. So again, you can sort of see right off the bat what sort of this problem is. And that's sort of where some of the pain points that Julia was really hoping to solve when the language was being developed back in 2012, which sounds like a long time, but as far as programming languages go, 2012 is probably sort of as new as a language can be. And again, the basic idea is that we now have the ability with Julia to sort of write code that a computer scientist, that any of us would be comfortable writing. And then you can actually take that code and it's fast enough and it's expressive enough and it's reproducible, and you can go and deploy that code into the real world. And the outcome of this is just more productivity for developers, which is definitely something that people seem to enjoy. So if we, again, look at sort of the high level for Julia, a lot of the really interesting stuff happening in the language and the ecosystem is in sort of the scientific computing domain. And if you're not familiar with scientific computing, it's basically just like all of the stuff that requires that you have sort of a domain specific knowledge, but then also some computing skills. And I think for me, this has always been one of the biggest challenges of being involved with Julia, is finding things that, you know, I'm sort of quote unquote classically trained in computer science. Like I understand computer science and I don't have a really strong sort of science background in any specific domain. So I'm always trying to like work my way through the water and find things that sort of my computer science specific background is well suited to solve. So if you're more interested in sort of some specific computing domain, whether it be biology or astronomy or what have you, there's a lot of really interesting stuff happening in those domains. But I also think there's a lot of really cool opportunities for folks who just know computer science and like to program. As far as the language growing, I think this is actually an outdated number now, 17 million downloads. This was like the last reported update that I made here, but it's actually up to 25 million as far as the beginning of 2021 and growing at a super exponential rate. 10,000 daily downloads. There's now over 5,000 registered packages in the ecosystem, which is awesome. Courses being taught all over the world at a bunch of really good schools and being used by a ton of really cool companies. And I think sort of to foreshadow a little bit for the future topic as far as why it would be a benefit for students to learn Julia. I really think that, and from my own experience, when you go and start working in a company, like they're not bringing you in because you know everything about computer science and you're going to be sort of running the show for computer science or software engineering at a specific company. They're bringing you in because you have a fresh perspective and you just went through school and you just learned the state of the art things. And I really think that that's one of the sort of selling points for Julia to students, is that you can learn something that other people don't know, and then you can go in and be the person to sort of share that with other folks. And I think that's something that I really have enjoyed doing as far as learning Julia and then going and getting to share with other folks, whether it be at my job or whether it be with other students. So I think that's a really cool opportunity to differentiate yourself from everyone else who knows Java, C++, and Python. And of course, lots of companies using Julia. If you look for Julia specific jobs, a lot of folks doing, again, computational stuff. I've seen some recent stuff with AWS, and a lot of research teams at Google are using Julia for some of the stuff. So there's definitely opportunities if you want to work and use Julia in a corporate setting. Also, lots of schools using Julia to teach classes and to do research. I think the notable thing to call out here is that there's actually a MIT course being taught right now using Julia, an Introduction to Computational Thinking. It's sort of I believe that the expectation is you have some sort of computer science background for this class, but it's being taught open to the entire world. So if you're interested in sitting in on those lectures and some of the discussions, I think it's computationalthinking.mit.edu is the URL, and you can check that out. And it's the professors are great, and the course material is really good as well. If we sort of this is one of the less interesting parts, but people have a lot of things to say about Julia, which I think is it can be positive in some senses. People often like to sort of attribute this like competition or war between Julia and all these other programming languages. If you look up Julia versus Python, there's going to be thousands and thousands of people talking about this, what's the new language, what's going to end up happening in the future. My personal feeling is that 10 years from now, all of these languages are going to be doing really well. Julia is going to be doing really well. Python's still going to be doing really well. C++ and Java will probably still be kicking, to everyone's surprise. So it's really not like a competition between all of them. Everybody likes to make it seem that way. I personally don't feel that it is. I think it's a positive sum game. Everybody playing is going to win, and it's good to be a part of that. So if we sort of think why specifically developers would want to use Julia, we sort of talked about this a little bit earlier, but some of the limitations between Python and Julia, if we think about sort of the design of Python and some of the specific attributes, you have this notion of Python being a high-level programming language. You have the fact that it's super easy to use, and it's dynamically typed. You can basically do whatever you want, which sometimes shoots you in your leg. But that is really one of the selling points and what makes Python so accessible as a programming language is that you can do what you want. And when Julia was being designed, the idea was, we should keep the positive things about Python. Like Python is a great programming language. I like programming in Python. It's awesome. But there's definitely things that, because of how easy it is to use and because of how sort of lax the restrictions are on what you do when you're programming, there is a bunch of performance hits that are sort of taken across the board. And also the fact that when Python was being designed, it wasn't designed to be fast. It was designed to sort of be usable by people, which it is, and it does really well at that. So Julia sort of comes in right in the middle, in that it's expressive, it's easy to use. Syntactically, it's very similar to Python. If you've programmed in Python before, you would be comfortable in Julia if I just showed you some code, which we'll look at later. But the intentional design of the language, and the fact that it's JIT compiled makes it so that it's much faster than Python. So you get this sort of a few orders of magnitude speed improvement right out of the box when you start programming in Julia. It's also scalable. It's in the Petaflop club, one of the few programming languages to be in the Petaflop club. Supports all the other stuff that you would want to do in a computational environment using GPUs, doing stuff on the cloud. It's reproducible, all that good stuff. And also, I think, again, as I mentioned before, a lot of the really interesting stuff happening with Julia is in the domain of scientific machine learning, a lot of these other computational domains. There's lots of cool things happening in there. So if that's something that interests you, Julia might be something that's worth checking out. So I mentioned before, the Petaflop club, basically lots of computational power, and there's few programming languages that have sort of been able to get up to this the scale that Julia has. So it's definitely something that's interesting. The Celeste project was sort of one of the example cases of this, where they were able to do 1.54 petaflops and do all this crazy computational stuff. All the nitty-gritty details are sort of over my head, but if this seems intriguing to you, definitely worth checking out. I know there's a bunch of good papers that are out there about this. Something that's super interesting, a really cool angle to Julia that's sort of taking off right now is sort of the notion that Julia is one of these tools that is going to help solve climate change, which I think is really interesting. And it's this Klima project, which is a collaboration between all the different things you see down there at the bottom, but they're headquartered at Caltech. Basically, what they went out to do was ask the question, hey, if we use some really state-of-the-art computational tools, can we actually build climate models that are like at the scale of the entire planet? And this is something hasn't really been attempted before the Klima project. And that's just because, again, the computational resources that you need to make this happen it's enormous. So the folks at Klima have sort of been the champions of this. And now there's a bunch of other projects that are sort of sprouting up around this. And they're all sort of focused on, how can we use the expressiveness and the speed of Julia to get a better understanding of what's happening in our climate, which is really cool. Before I just continue to charge forward, any sort of questions that anyone has that have come up so far?
Yeah, I think, like you said, feel free to ask questions throughout the presentation, just using the chat. I think it will be, very engaging. I guess like my question is like, how recent was this Klima project? I never researched into this, but how recent it was probably.
Yeah, this is a super recent project. So I actually went down there and visited them in like spring of 2019. And that was sort of even in the earlier stages of the work that they were doing. And now I think things are more further along than they were before, but definitely still in active development taking place today.
Okay.
That's a good question. Any other questions before I charge forward?
So Max asked, is Julia statically typed?
is Julia statically typed? No, thankfully it is dynamically typed. I was programming in a language called Solidity, which I don't know if anyone has heard of, but it's also some like a very niche language right now used for Ethereum blockchain development. And I hadn't programmed in a statically typed programming language in a couple of years because I've been using Julia and Python for everything. And it was such a different experience to have to go back and tell the compiler what types I wanted everything to be. And it made me appreciate dynamic typing a little bit more. But yeah, good question, dynamically typed. So again, we were talking before about sort of some of the interesting computational problems that are being used or that are being solved using Julia. One of the really, really cool ones that I actually had a chance to be a part of is this project called Pumas. And it's I think the original intent was to set off as a platform to personalize medicine for individuals and use all these state-of-the-art computational tools in order to personalize medicine. Like I think about this all the time. It's just such a weird thing that, you know, we all go to the doctor. We all have completely different physiologies. We're all different heights, weights, sizes, you know, all eat different things, exercise different amounts. And then we go to the doctor. And for the most part, we all get like, if we get the same prescription, it's like the same amount of medicine for all of us, which is such a weird thing to me. Like that just doesn't make sense that's the case. Like we all eat different amounts of food. It's not like we all eat the same amount of food and drink the same amount of water. So why would we all get the same amount of medicine for a disease when our body is different? So Pumas is sort of hoping to help solve that problem. And along the way, they've gotten into a bunch of partnerships with Pfizer and Moderna, and more recently actually helped with one of the vaccines for, I believe it was Moderna, and they're actually using Julia to speed up the development of vaccines, which is really, really cool and super impactful work. So the people at Pumas have been doing an incredible job, and I got to be involved in a really tiny, small capacity, but it was still cool to see all this awesome stuff happening.
I think that's crazy because like we all know how you know, I always thought about like how machine learning or just like how anything involving, you know, programming can be used in like, you know, vaccine research and speeding up that process. And yeah, I think it's really exemplary how, you know, programming takes us not only just, you know, creating software, but like how can it like help us in the real world in cases like the pandemic, right? So I just think that's just amazing.
It is. It's super amazing. And I think the statistic from Pfizer is they help speed up the drug discovery process at Pfizer by like 175x or something ridiculous like that. Like they used to run some of their computational simulations, it would take them like a day or two. And it's taking them like, I don't remember if it was a couple of minutes or like 20 minutes or something like that, but just a crazy difference in how fast they can iterate. And I don't know if anyone here has looked into the sort of backstory on the coronavirus vaccines, but they actually, and I don't know if this is specifically related to Julia development or not, but just generally, they were able to actually come up with the vaccine that they're now giving to people within like 3 days of getting the genome of the coronavirus synthesized. And that was like months and months and months ago. They had the vaccine in its final form, the form that they're injecting into people's arms right now, but then they had to go through all of the rigorous testing process to make sure that it works. But it's crazy that they were able to sort of develop that vaccine so fast. And hopefully Julia was involved in that process, though I don't know that for sure. And again, just at a high level, some other really interesting use cases, just sort of showcasing how in the dynamic way that the language is being used. The FAA uses Julia. So in order to sort of route airplanes to make sure that the collisions don't take place in the sky, they're actually using Julia to develop that system. It's called ACAS-X, and a bunch of folks at Stanford using Julia, they were able to develop the system, which is really cool. BlackRock, which is the world's largest asset management company, is using Julia for a bunch of analytics and prediction stuff. The New York Federal Reserve, and there's a ton more interesting use cases on juliacomputing.com. So if you're intrigued to see what other cool ways Julia is being used, I would definitely check it out. Again, there's also some, and we sort of alluded to this earlier, there's some really interesting development happening in Julia around the computational science area. So I would say that one of the pain points right now in the Julia ecosystem is actually that, you know, if you go and program something in Python, like there's a good chance that somebody else has also programmed the same thing or has built a package around it. Like if you want to do whatever it is, you know, somebody has built something to do that in Python. And that's actually just factually not the case in Julia. I think my personal feeling about this is, depending on what you want to do, it can definitely be a pain point, but it's also a really cool opportunity to like actually get involved and like solve these problems for people that then someone for the next 10 years is going to use your whatever package it might be in order to do something for, you know, a company or a specific project. I think that's really interesting. There's also a lot of packages in the Julia ecosystem which are actually like leading the way, best in class packages. And a lot of that stuff, again, is in the scientific machine learning domain, the whole differential equations package and the SciML stuff. That's all the infrastructure which is enabling a lot of the stuff that we talked about with Pumas in the drug development acceleration process. So lots of really cool stuff happening, and there's tons of resources in those areas, which is always cool to see. So speaking really specifically about opportunities for students, so the Google Summer of Code is a project in which we're involved in every single year. This session we're involved again, which is really exciting. So you can actually see the timeline right now, I think, is the exploration phase. So students are just checking out projects. I'm not sure how familiar you all are with Google Summer of Code, but it's basically just a quote unquote internship program put on by Google every summer, and students are able to basically go and look through projects created by open source organizations, and you get paid by Google a stipend over the summer to work specifically with all these different projects. So really cool opportunity to get involved with open source. Last year, we as an organization mentored 24 students, and then we also had 11 students in the Major League Hacking Fellowship, which was really cool to see as well. So lots of cool opportunities to get involved. You can check out the website and look at some of the projects to see if they're interesting. There's a question in the chat, and the question is, can Julia be interfaced for external libraries such as C++, Python, and Java? So as far as interpretability and interpolation, calling other languages from Julia is really easy. So there's a package called PyCall, and basically you can embed Python directly into your Julia code. So essentially, if you have some really good Python code that you never want to rewrite for whatever reason, you don't have to rewrite it in Julia in order to run your code. You can literally embed the code right inside of Julia. Same thing exists for R. There's an R call package. I believe the same thing exists for C++. As far as those languages calling Julia and interpolating that way, that I don't know off the top of my head, because I don't actively program in Java or C++, but potentially that's possible as well. That's a really good question though. But yeah, going back to this slide, the high level gist is there's cool opportunities if you're interested in using Julia over the summer, getting involved and sort of doing a round with Google Summer of Code. I would definitely check it out, and not even specifically to the Julia language, but just generally, Google Summer of Code is a really cool opportunity. So definitely get involved if that's something of interest to you. Cool. So if you want to sort of follow around and play along with me, I really don't have very much specific stuff to show you as far as code goes, but I'll just roll through some syntax just at a high level to show you that it's quite similar to Julia. and maybe perhaps Joshua will show us some cool stuff that he's working on. But let me switch over which screen I'm sharing, and that way I can share my IDE and we can look at that. Awesome. So I have Atom open here. If you're not familiar with Atom, just another run-of-the-mill IDE. The standard IDE for programming in Julia is VS Code. I just use Atom because it's what used to be the standard IDE for programming in Julia. So if we just take a look at what's going on here, project pane, sort of my code over here where I type stuff in, and then we have the REPL down here. Julia has a REPL, which is the read, evaluate, print loop. And if we go ahead and turn this on, I can sort of show folks what the interesting pieces are that I really enjoy about Julia. Let's just complete our hello world really quick. And we'll wait for the REPL to turn on. Come on, you can do it, REPL, turn on. So what I'm going to show right here in the REPL is the package manager. So if you're familiar with the Python package manager and you're super comfortable with it, I would actually ask that you take over sharing and sort of explain it to everybody, because I have no idea how the package manager for Python works. Pip is sort of a black box to me. It's really unclear how to manage my dependencies, what I have installed. I don't like the interface at all. And I really, it's truthfully one of the honest reasons that I stick around and continue programming in Julia, because I can literally simply type this command or that character right there, the left facing square bracket, into the REPL, and then it'll take me into my package manager. So I type that and I'm now in the package manager, and I can type status, and this will tell me exactly what packages I have installed in this particular environment. And I can really easily switch environments so you can see all the packages, what the versions are. It gives me the path to the specific file that's managing my package installations, which again, if you've done development in Python and you've tried to handle package dependencies, it's such a challenging thing to do. And this is sort of such an easy process in order to make this happen. So you can see all the packages I have installed. I can go ahead and do add, and then there's a package out there called test, which is quite literally a test package, and I can add it. And then it's automatically going and basically doing git clone and all that stuff and adding it into my my package environment. While we wait for that to happen, go back and look at this hello world example. So print syntax, literally the same as it normally would be. If you define, some string and then have it be, this is a string, and then we do sort of the basic for letter in some string. Everybody's familiar with the syntax. If you've programmed in Python before, then we can just print letter. And then the only difference, and this is sort of the weird nuance of every programming language, the way that you end a code block is always different. In Python, you have the colon for ifs and fors, and then you use indentation to denote what the end of a code block is. In C++ and Java, you use curly braces. In Julia, you use the end keyword. So when you define a function, an if statement, a for loop, you just put the word end at the end, and then you're good to go. I actually like this a lot. It's one of the annoying things with programming in Python is I have to like blow my screen up really big and like draw a line down the screen to try to figure out like where the end of each code block is, to make sure that I have things in the appropriate scope. So I've actually gotten in the habit of, when I program in Python, I just comment out the word end at the end of a block so that it's easier visually for me to denote. where the beginning and end of certain things are. So we could see what was happening there. It was just taking a while because I need to get a new computer, but we were able to add a package into the environment. We can actually, again, specifically remove packages, remove test. And this sort of ecosystem, these project and manifest files are how you can make your code reproducible. So if I have some dependencies for my project, I install them, and then I send you the packages. Or if in a real world example, if Joshua takes his code, which he was writing in Julia, and he makes sure that the correct packages are installed for the project and manifest file, and then he sends it to me on my computer, I can literally open up his project. I can do activate, and then I can type in the word instantiate, and that will literally activate his project, instantiate, and then download all the dependencies, and boom, I can go and run his code. And it's literally that simple. So that's, again, one of the really cool things that separates Julia from some other languages like Python, is that you have this reproducible environment, so you can spend less time sort of trying to get other people's code running and more time actually doing whatever it is you enjoy in programming. So let me just run this really quick to make sure I didn't do anything and I'm not lying about the syntax. But there we go. We're seeing hello world, and then we're looping through all the letters and some string, and that's doing the job for us. I think the only other worthwhile thing to sort of mention is the structure of packages, and how in the Julia ecosystem, a lot of people sort of have this, I don't know if it's an initiative or it's just sort of the norm in the community, but when somebody builds something that they think other people might be able to use, they don't just like leave it as a .jl Julia file and just put it on the internet. Everybody makes their stuff into packages. And then if I wanted to use somebody's package at the top of my file, I would just say, like in this example, using test. And then whatever the exported functionality is from the test package, I can now implement that in my code and take advantage of it. So that's sort of the really, really basic introduction to programming in Julia. Again, there's lots of great resources out there if you want to learn more. And I'm happy to answer any other questions that folks have, but that's all I have. Hopefully it was engaging. And again, I think one more really quick piece is that I can't emphasize enough the sort of opportunities that folks have in the Julia community. I think for me, this again has been something that's kept me around for a long time now, is that, you know, if I want to go post a question on Stack Overflow, you know, so if it's a Python question, someone's already answered it. It's really not going to help that many people. And I think I have questions posted on, I post questions on Stack Overflow for Julia all the time, which, you know, over the last 6 months are getting like 2,500 views, which to me means that the questions that I'm asking on Stack Overflow are actually helping people. People are looking for these answers, and I'm able to contribute, which feels really great and is a really cool opportunity. And again, very different than some of these other more saturated communities where you know, the only way to do something different is to sort of reinvent the wheel, which isn't a rewarding process at all. So lots of great opportunities, and if I can be of help, feel free to reach out to me. But that's all I have. Is there more questions I can answer?
Yeah, I had a question.
Sure.
I can ask. Thanks again for this talk. It was super interesting. I never heard of Julia before, but I just wanted to ask about kind of like you mentioned that Julia is faster than Python, and I know with like since they're both dynamically typed, like in Python normally like you would like import numpys or something for like loops and stuff, because it has to, the compiler I think has to check the variable at like runtime. If it's like you're doing a loop, it has to check that variable every single time. And so like with numpys, obviously like it's like I think it's written in like C++ or something, but essentially it just doesn't, it will like make it so you won't have to check. So is there something like equivalent to that in Julia, or does it have something else built in to make it faster?
Yeah, Max, that's a great question. And that sort of gets at the core conversation around Julia versus Python, because a lot of folks will say the exact same thing that you just said, where, yeah, and it's true that in Python, you can use NumPys and you can use Cython and all that stuff to improve the speed of your Python code. The challenge with that is that there's a bunch of limitations as far as what, like, you can't, it's not base Python, so it doesn't apply to everything, and it's not like a general solution. And I think my understanding of this difference, and I'm not a super deep compiler person, so compilers are just magic to me, but it's the intentional design of the compiler and the language itself which enables this speed improvement. And I mentioned way earlier that Julia is JIT compiled, but folks in the Julia community actually say that JIT stands for just in time compiled, but people always say that Julia is just ahead of time compiled, which sort of gets at the magic that's happening, or not magic, just really good computer science, in that it can sort of infer these things ahead of time before it actually needs to compile them. And that way you're not taking a performance hit. But more directly to answer your question, Max, there's nothing specific that you need to do to see the performance increases when you're programming in Julia. There's obviously some performance pitfalls and things like that that you would want to avoid, but out of the box performance should be quite comparable. And I'll look at a really quick benchmark between the two. Does that answer your question, Max?
Yeah, that does. Thank you. That's awesome.
Of course, yeah, great question. If we look at this, and these are just some of the micro benchmarks. But if we take a look, and I say micro benchmarks because these are all basically toy operations that don't really make that big of a difference. But if you look at some of them, like matrix multiplies, recursive, Fibonacci, print to file, you see Python right here, and sort of some of the time complexities that are involved with a lot of these different operations. And then if we look at Julia over here on the far left-hand side, you're seeing these operations all take place at a speed which is close to constant time. So it's super impressive for this to be able to happen. And these results have actually gotten better. I think I was having a conversation with someone about this. They've probably gotten better for all of these languages, but I think specifically with the upcoming Julia 1.6 release, you'll see all these numbers go down. So it's super impressive. And again, this is out of the box, no sort of super magical stuff happening here. You're seeing 2 orders of magnitude increase in speed, which is awesome. And then when you have a really well written computational example, like some of the Pfizer stuff, that's where you can see those crazy speed improvements, like 175x improvement in speed.
Yeah, I think like what you're showing us right now, I think this is like quite impressive with how the language is able to, in terms of its like general time complexity and just its overall performance, right? I think it really allows for like all these operations to be performed in like such an efficient manner. And I think you've done a great job of compelling me to try wanting to, using Julia maybe in a lot of applications. So I think this brings me to my question of if I want to like learn more about Julia, let's say, I'm not, the most avid programmer, and I actually, want to get into Julia. So the Julia website has like these resources to get us started.
Yeah, that's a great question. And I think I'm sort of in the same boat as you, where I literally consider myself like an advanced beginner. I'm just dangerous enough in programming where I know how to get myself in trouble. And I think that there's enough resources in the Julia ecosystem where you can really learn what you need to do to take advantage of the language. And whether it's Julia Academy, which is sort of our curated courses for learning Julia, for learning machine learning, for learning data science, all in Julia, or there's a bunch of great resources on our YouTube channel And then the only other thing that's really interesting that if folks haven't checked out is definitely worth it, is this platform called Exorcism. And on Exorcism, there's like these curated, basically like computer science problems that you can solve. And the cool caveat is that there's like real mentors who evaluate your solutions and provide feedback on them. So it's a cool way if you sort of don't like the traditional learning in a classroom setting and you just want to go program and solve problems. Exorcism is a super cool platform to do that. And there's Julia mentors on there who will just answer your, or will look at your code and sort of give you feedback. So really cool opportunity if that's the way that you like learning.
Excellent. So yeah, if you guys wanted to check out learn Julia programming, go ahead and check out the website. I did put the link to the general website itself in the chat if you guys want to check it out. So yeah, go ahead and give it a shot if you guys are interested. And Logan just put it as well. So yeah.
Of course. I want to give one more really quick plug to if you all have not heard of Code in Place, it says right here, a free human-centric introduction to coding in the time of COVID, put on by Stanford University. And I think for folks here who sort of know computer science and are engaged in the sort of ecosystem, applying to be a teacher is such a cool opportunity. If you've never sort of taught computer science before as a TA or something like that, it's a great learning opportunity for you to teach other people. And also it's sort of great to see, having a direct impact on somebody's life and helping them learn how to code. So you can apply to be a teacher and sort of mentor 10 students. I was a part of this last year, and this year I'm helping sort of organize. But last year there was 10,000 students, 900 teachers, and this year it's gearing up to literally be the largest class that has ever taken place in human history based on the number of teachers. So if you want to be a part of history and teach people to program and also become better at programming yourself, this is a really cool opportunity, and you can check it out. The URL is just codeinplace.stanford.edu.
Sorry, I also had one last question.
Sure.
That's okay. I know you mentioned you got familiar or you started with Julia because of your NASA internship, right? And you had to kind of learn that way. But I was wondering if you could talk just briefly about how you started getting involved with the Julia community, becoming a community manager, et cetera, and what that role entails.
That is a great question. So it is an interesting story. I was using Julia at NASA just like anyone else who normally consumes a programming language. Like I was just using the language, and I would open issues occasionally and be like, hey, I can't do this. Can somebody help me? And that was sort of my first introduction to open source. And then as time sort of went on, I built a couple tools for the ecosystem. One of them was literally just a bot that every time someone posted a question on Stack Overflow, it would like port that over to our Slack workspace, which has like 10,000 people in it who just answer Julia questions all day. So I got involved with that, sort of had the opportunity to meet some folks because of that process of building that tool. And then in 2019, I helped out as a mentor and an admin for a program called Google Code-In, which was, it's discontinued now, but Google used to put on like a Google Summer of Code equivalent for high school students. And the Julia language basically mentored 212 high school students. And I sort of got to lead that process. And I really enjoyed just helping people learn how to program. It was a ton of fun for me. And I emailed the people who I knew who were sort of in charge of the Julia language, if you will. There's no one really in charge. It's an open source programming language that's under sort of fiscally managed by a nonprofit. But I emailed the maintainers and the people who created the language. I said, hey, I'd love to help out doing educational resources. And they were like, sure, cool, you can do that. And then I started doing that at the beginning of 2020. And then literally one day, my manager, if you will, messaged me, and he was like, "Hey, we used to have this community manager title. Nobody has it right now. Would that be something you're interested in?" I was like, "Sure." I don't really know what that entails, but I'd be happy to do that. And then at that instant, everything changed, because it used to be that I was just involved with sort of focused on educational resources and things like that. And then as soon as I became the community manager, the scope and domain of what I do now is literally everything. The way that I think the best way to explain it is it's basically a startup, and I'm the only person who is fiscally supported to do Julia activities. So basically everything falls on my plate, whether that be outreach for partnerships, getting to chat with folks like you, which is really not necessarily work, but I just enjoy getting to share the good news about Julia. All the administrative, logistical, managerial stuff that you could ever imagine. A lot of it is not a lot of fun. A lot of it is really cool and interesting. But it's been such a great experience for me. And the piece that's really interesting is, again, I think Julia is such a great tool and resource and opportunity for folks. And I also think that the work that I do for Julia stuff is completely different every day. Like one day it's helping plan Juliakhan, which had 30,000 people virtually attend last year. And the next day it's like making thumbnails for YouTube videos. So it's all over the place. It's completely different, but I enjoy it a lot.
Yeah,
That's a great
that sounds
question.
awesome. Yeah, thank you.
Yeah, of course. Again, I think that, I could harp on this for an hour just by itself, but I think that's the lesson learned in that story is, if there's something that interests you, reach out to the people who are doing it. I do this all the time still to this day. Anyone who's doing anything cool, I'm like, hey, like, let's talk about it. I just want to hear more. And most of the time it leads to nothing, but sometimes it turns into a really cool opportunity. And I think that's what this is for me. I just had no expectation, reached out, ended up working out, and it's had such a profound impact on me. So I'm super grateful for the experience so far.
Yeah, I think that's like honestly just an excellent mindset to have when something interests you, just go for it. And you said it right then and there. I think that's like the approach that a lot of people just should take when it comes to interests and whatnot. So yeah, thank you for like sharing advice on that, and just talking about obviously the language itself, talking about your experience. I think you really like shed a light on a lot of aspects today that I think a lot of our members are going to get a lot of insight from. So thank you for that.
Yeah, of course.
So does anyone else have any other questions to ask? I mean, I guess I should ask. I didn't have this question earlier because you had just mentioned it, but you had mentioned something about Juliakhan, like some sort of convention, right? So
Yeah.
can you kind of like just go over that, like briefly, like what that is, and like what do you guys do here at this convention?
Sure. It's just an opportunity. It used to be physically held in person. I've actually never physically attended Juliakhan. I went virtually last year, and now I'm on the organizing committee this year. But it's just a conference where people who enjoy doing Julia stuff get to go and share some of their experiences, whether it's literally their experience. Like we have an opportunity where you can just learn. People who just learn Julia can share about what they enjoy for 5 minutes. And if you have a cool package and doing some state-of-the-art computational stuff, you can go and talk about it. So just a cool opportunity to get together with folks who enjoy programming in Julia. And that actually, if anyone picks up Julia, Joshua, perhaps this is an opportunity for you. The call for proposals for Juliakhan is open until March 31st. So if you want to get the experience of sort of a low-key experience of talking at a conference, this is a really cool opportunity to do so. You can do a 5-minute talk, a 10-minute talk, a full-on 30-minute talk, and it would be a great experience. Juliakhan 2020 was my first experience ever giving a talk at a conference before, and it went seemingly okay. So I would encourage you all to get involved. And one of the questions in the chat is, how do we get in contact with you? If you want to shoot me an email, if that's easiest, it's just logan@julialang.org. you can also find me on the internet places and send me a message there as well. So, and the only other piece of advice, going back to what we were talking about before, is about applying for things. The cool part about the internet is that there's little to no social consequence for applying for things. Like it doesn't cost you anything besides your time, and no one is gonna like laugh in your face because it's the internet and you can't actually see the people. So that's really my incentive and my motivation, and sort of the freeing piece for me when I send somebody a message to get involved with something is there's no consequence. And don't take that and be a jerk on the internet. I sort of take that as my ammunition to go and just not worry about what people think. If there's something that's cool to me, I go and reach out to the person. So hopefully you all can do that as well.
Yeah, that is actually a great point that you brought up about just go for it. Why not? It's the internet, not really much consequence. But yeah, Logan put his email in the chat, so there's a line of contact for you guys. If you guys want to talk with him further about anything else, you guys can go ahead and do that. Also, I put a reminder for the sign-in sheet. If you haven't signed in already, you can go ahead and fill that out. Most of you guys probably have. But yeah, unless there is no other questions, we'll be ending this shortly. But before we end, I just wanted to say once again, Logan, thank you very much for your time. Like I said, I know everyone here most likely got a lot of insight from a lot of things that you said, that you went over, and like I said, you definitely compelled me to research into the language. So I'm most likely going to be doing that. But yeah,
Awesome.
thank you.
I'm glad. And again, yeah, I appreciate the opportunity to talk to everyone. And if there's other questions I can answer offline, feel free to shoot me an email.
Yep. All right then. Well, thank you for everyone for joining, and we'll see you at the next meeting. Bye, everyone.